Okay, here we go. Now, okay. All right, what lesson are we on? 3-5. I'm changing 3-5 to just one day. These are your problems I want you to do for Monday. That's it, and then we're done. You come back Monday, it's review time. Come back Tuesday, it's review time. And come back Wednesday, it's time to perform. It's a big one for you because you have 3 tests in quarter 2. We already took the chapter 2 test. Here comes chapter 3. All right. I shaved this lesson down. I shaved it down pretty good. I put on there what I know is on the test, and maybe just a little extra. But pretty much this is what you're doing today, right about here. We're going to go into exponential models, so story problems where you have to dig the information out and come up with equations and use the equation to answer the question. You'll see a little bit of this, but not much. Okay. All right. So where are we going to go? We're cutting this down quite a bit. It is not that one. The first slide, we're not going to do it. The second slide, we're going to talk about this. And then below this, isn't there story problems on rabbits? Yeah, we're not doing that either. But this is what we need to talk about. Okay? All right. So I think you're on slide 3 already. Okay. You and I are going to do story problems and exponential growth and decay. And here is the general model, the model that looks like growth and decay. Y equals a times e to the bx. Now, normally you think of it like this. This is how you think, right? Whoops, that's pert. A equals pert, okay? That's how you guys think of it. It's the same thing. They just change the letters. Now, the x and the y, the x and the y, they're just points on your graph. They're just points on your graph. Now, you're going to have either what? Growth, or you'll have what? Decay. So if I just draw you a quick growth problem like this x, this y, that's like, if they just give you a random point on the graph, that number x, that number y, get plugged right here in for x and y. Okay? The a, what's the a? It says it right here. Original amount or value. Okay, where do we find the a on the graph? It's the y-intercept. So if you want, you could just say this is a. Okay? I mean, you just draw a little picture. Now remember, this could be decay. I just drew growth for you. Now, the question is, this R stood for your interest rate because we were talking about money. Well, this is a story problem, and we're not always talking about money. So this R becomes the coefficient in front of the time. Okay, they call the time X, and this is the amount of what's there. Okay. Now, one quick thing: if your B value is greater than 0, you have what? Growth. You'll have that picture. If your B value is less than 0, you have decay. And decay, I think you guys know it goes like this. Okay, it goes like that. Okay. What is this B called? It is the growth factor. But if B is negative, you have to call it almost the opposite. Not the growth factor, but the decay factor. How fast am I going down? Okay. And that's really all I wanted to tell you on that slide. The rabbit problem, we're just not going to do. Okay. Move on. Here's the one we're doing right here. Now I'll do this one, but the next slides, you're kind of on your own. If the graph of the function y equals a times e to the bx passes through the point 0, 2 and the point 4, 10, what are the values of a and b? They gave you 2 points, right? Yeah. Which points? 0, 2. Okay, right here. And 4, 10. Well, that 10, I suppose. Right here. Okay. And because it's in that pert form, is it growth or is it decay? Yeah, you can kind of see it's going to go like this, right? It's going up, and it's going to ride the y or x-axis. Okay, good. All right. They want the value of a. You guys Noah says 2.
I see.
Starting point 2. And we take off and we grow. Okay? Is that okay? Can I just say A is 2? All right. If you don't know though on a test or a quiz or whatever, you could very easily just set this up. B to the x, okay, and then y. Okay, you want A times B, and then the B you don't know B right now. You'll find B later. This x. To me, the starting point is when I start right at 0 on the x-axis and I take off. So I'd let x be 0, and I'd try to figure out the starting point, which is y. I know you guys know it's 2, I get it, but just let me show you how. In case they don't give you this point, put 0 in for x and see what happens. What is this? E to the 0, right? E to the 0 is what? 1, and 1 times A is what? A, so it's A equals, sorry, you'd have to plug this in, I guess, 2. Y is 2, so you'd end up with 2. It's just too easy, isn't it? It's just 2. I hope you don't have to do anything like that, but if you do, you do. Sometimes you have to kind of read into the problem to get the A, and you'll see in the next slides. Okay, now, what's B? Okay, let's use this formula right here, guys.
I like that.
Okay, here we go. We want B, so it's E to the BX. We already know the A is 2, right? Okay. What do you think?
4.
I need an X and a Y.
4.
410. They gave you 410, use 410. I think I can stop talking. I think you can solve for B now. Is this a log problem or is this exponential? It's exponential. There's no mention of log. It's exponential. Go get it. You've done 3 days of solving equations. You should be pretty good at this. Isolate the base, e to what power? 4b, e to the 4b equals 5. Now, what do you do to both sides? Oh, I already divided by 2, sorry. Take the log of both sides, but it's base e, so let's take the natural log, right? Where am I going to put the exponent, 4b? In front. 4b times the natural log of e equals the natural log of 5? Tell me you know this. The natural log of e is what? E to the first is e. So it's 1. So this is really nothing. You don't even need it. You could just kind of like do this. That's just 1. So the answer is B is roughly, divide by what? 402. Can you give me one more?
3.
3? Okay. It's really nice if you go about 4 out on this because you're going to be asked questions later. Like, what is this point? And if you have a better B value, you get a more precise answer, okay? Did you read this? Now they want you to write a model that would fit this graph. Well, your model has a B value of that. You have an A value of that. So let's come down here. Where's the model? Y equals 2 for A times E times X. Right? Okay. So this equation, this formula, this model, whatever you want to call it, this will get you any point on the graph, right? So if I said to you right now, this is 4, you get what? 410? Well, what if I said, what's it going to be if you plug in 8? what could you do?
Toss 8 in.
8 goes there. Punch it into your calculator. You get what? Right? That's all it is. Got it? This is why you have to find this formula. This formula is you're going to write the formula, and then they're going to say, what if x is 12? What's y? What if x is 200? What's y? What's y? Okay? That's the final answer, by the way, right there. Okay. Questions? Okay. Half. Yes, we're doing half. Okay. What is half-life? Well, here it is. It says here, the half-life of anything. The amount of time necessary for a substance to be reduced to what? Half of the original amount. Okay. So, if you were told that something disintegrates, let's say, to half its weight after 200 years. So after 200 years, let's go, something weighs 200 pounds, and I tell you in, I don't want to use 200. How about this? 500 years go by, that equals the half-life, okay? Okay, so how much of that is left after 500 years? 500 years go by, what's left? How much? 100, yeah. Whoa, got carried away. 100. How about 1,000 years go by? 50. Good? You getting this? That's all it is. But see, you're not going to be asked these easy questions. They're not going to say 500, 1,000. They're going to say 1,222 years go by. How much is left? So you need a formula is what I'm trying to say. Okay? So here's your first problem. It says this. If a certain substance has a half-life of how long? 40 years, which means after 40 years, what's left? Half of it. After 80 years, half of that. Okay? What is the equation that models the decay? Okay, talk to your neighbors and do it. I just did a problem for growth. This is decay. Ooh, that doesn't work. How are we doing?
That's what we have.
That's what you have right here? Okay. All right. All right. 40 years go by, right?
Yeah.
Okay. So what is left after 40 years? Half of what you started with. What did you start with? A. Start with that number, right? But what did you start with? What? 200 pounds. Okay. You know what Noah's doing? Noah's saying 200 pounds, but he's just doing this. He's just picking a number at random. 200 pounds. Could I have said 100? Could I say 30? Yeah, he can say anything I want. He says 200. I'll go with Noah. Says 200 pounds we start with. And Noah, do you know what's over here? 100. Exactly. Because you know this is what you start with, and this is what's left after 40 years. Right? Times e to the bx. You never know b. You have to find b. What's x? 40. Because in 40 years, 200 goes to what? 100. This is the y value. Start at 200 on the y-axis. And guess what? You're down to 100 after 40 years. Right here. Boom. The A was not given to you, but you have to know what half-life means. You can pick any number. I don't care what you pick. You could have picked 20. 30, you can take 1, 2, 3, 4, I don't care. But whatever this number is over here, it's gonna be half of that number. Okay, go get it, go get B now. Should be fairly easy for you to get B now. Divided by 200, you get what? 1/2, 0.5, whatever you want to put. Okay, you know it's e to a power of x or whatever your variable is, it's an exponent. It's exponential. You do what to both sides? Take the natural log of both sides. I did it. I stuck the exponent out in front. I know ln of e is what? 1. I can just do this. Okay. So now it turns out to be b equals whatever this is divided by 4. Oh, should b be positive or negative?
Negative.
Why negative?
It says decay.
It's half-life. It's going down. Okay, so what is it? Negative 0, what?
Oh, just 1 0.
Just
Sorry, 1 0. Then what?
1732.
173.
32.
That's an approximation, but that's good enough. It will get you close enough to the answer that we need right now. Okay, now what? Let's write the equation. Here we go. The equation is y equals the starting point, whatever that is, times e to the negative 0.0173 times x, right? Okay, now remember a can be anything. Y will be half of a, okay? Next question that I have is this. Could you guys see that?
No.
I blocked it up, okay. What percent of the substance will remain after 30 years? Hey guys, what would be left after 40 years? How much is still there? 50%. Okay, so after 30 years, you're expecting what? Less than 50 or more than? But is it more than 50 or less than 50?
More than.
It's more than 50% because this is not quite half-life. There should be still more than half there. Go ahead and figure that out. Where are you going to put this? 30. In for what?
X.
Yeah, guys, look up here. Where'd you put the 40?
You put it for X.
Yeah, you put it for X, okay? All right. So here we go. Goes here. Okay. E to the negative 0.0173 times 30. What's left after 30 years? Well, here's the deal. What did you start with? Noah said 200. I could put 200 back in, but he's picking an awfully big number. How about probably the easiest number there is?
2 and
1.
Don't go with big. Okay. I'd do 1 if I were you. And now what's left after 30 years if something weighed 1 pound? That's what we're looking for.
Type it in.
Yeah, there's no solving here. It's more type it in than anything. No, you don't even need the 1, by the way. But let's just keep it there. What's left after 30 years? Point 5 what? 9.5 roughly. Okay. Now guys, if you started with 1 pound of something, and 30 years later that's what's left, what percent is that? Yeah. All right. So what we're saying is there's about 59.5% left. You know, if I would have did it with Noah's answer, the Noah's 200, the problem would have been, it would have came out like 119 pounds or less. Well, then I'd have to take his 119, divide by his 200 to get the 59%, and that's more work. I don't want to do that. Start with 1. You okay? Here's another one. Half life. Half life. Go. You should be a little better now. You should be able to function. Let's see if you get this. This is this radium. Radium. Isotope 226. That really doesn't mean much to you, so don't worry about it. Okay.
Yes, it does.
Huh?
Yes, it does.
It doesn't mean much in this problem. Is what I'm saying. Yeah. It's just telling you have radium. It's gonna disappear. What? No. Hunter, you're not gonna talk to her about the problem, are you?
Okay.
I'm busy. Maddie? No. Okay. Well, how'd you start it? You know, you guys gotta find what letter?
B.
B. B. Find B. Okay, so I don't know B, but I should know everything else, right?
Plug numbers.
Yes.
What'd you plug in for A, the starting?
12.
What?
I put 12.
You put 12 and you put 1. Now you got off that 200 and went to 1, huh? Okay. Guess what? You can put anything you want in because it doesn't matter. I can put Hunter's number in. Noah, I would put yours in, but I want to show the class something. If I put Hunter's number in, what's over here?
6.
Half of this. It's called half-life. Times e to the bx. But for 12 to go to 6, how many years have to go by? 1,599 years have to go by to get 12 to go to 6. So you put this here. Okay? Now, if I drew you a quick picture, you might want to do this, by the way. This is decay, and you know it goes like this, right? Okay, here's the deal. Since I went with Hunter's 12, I'd have to put Hunter's 12 right here. Okay? And then basically, it says 1,599 years from now, right? How much is left? Half of it, 6. So you get what's happening here? This is the timeline. 0 gets you 12, 1599 gets you 6. More or less, you should be able to solve for B now. Go get it. I took the natural log on one side, the natural log on the other. You guys realize that this happens every time? What do you get every time? 0.5, half. It's called half-life. You can just put it there if you want. But you might want to show yourself a little bit of work. Okay, here we go. This is gone because it's really just 1. Divide by what?
1599.
1599. Help me.
Negative 4.335.
No,
Yeah,
No,
there's
no,
4
times
zeros
10
in front of it.
negative 4.
10 to the negative 4th means what? Move it backwards 4. 0.000.
0.
0.
0.
Give me one more, please.
3.
3. Okay. Got it.
Times 10.
Okay. Write the formula. Here we go. Formula will be y equals a times e to the, wait, this should be negative.
It is negative.
Okay, negative,
There it is.
Paul, which way is north?
That way.
I'm north, okay? Alright, x, okay? Then, is there more? Is there another question? Oh, yes. Okay, if 12 grams of substance were present when? At 1,000 years. At 1,000 years. Okay, so here's 1,000. Okay, so there's 1,000. That would be what? 12. Uh-oh. My problem is I listened to Hunter with that 12. We should have just did the 1. Okay, that's not the starting point. So here's the deal. Look, we need the starting point. What was the original starting point? Well, if you know this point on your graph, 1,000 what? 12. What are you putting in? For y, you'll put in what? 12. For a, the starting point, I don't know it. E to the negative 0.00043 times x. X was what? 1,000. Okay. And you're solving for what? A. Well, there's A times this number. This is just a number. So divide the whole thing by D to the negative 0.00043 times 1,000. A is what? 18 point. I can't remember if it was. I think it's something like that. Something like that. I can't remember. I'm pretty close though. And that's grams, by the way. That's grams. Hey, you guys know that I changed assignment, right?
Yeah,
You know it now, right?
I took a picture.
Okay, we're not going on Monday. We're done. Get that done. We must on Monday. So you take the quiz?
Yeah.
Okay. Okay.
All
All right.
Do you want
Oh, what's that? Yeah, that was good.
Okay, you're staying here.
Hey, remember us?
Mr.
Painter.
Mr. Baker. Mr. Baker.
And then he's like, oh, you're just so tired. Oh no, it's just me being depressed. That's not what that's not me. Okay, next time. Hey, wait, did you catch that? Is that why you're laughing? Just me being depressed because I'm a boyfriend who doesn't love me.
Don't date him anymore then.
That's not like theoretically.
Like a year ago. Because I have a boyfriend that doesn't love me. Hey,
Then that is
you saw one of your brothers.
Alberta. Nutty. Snapchat. You know how I'm constantly talking. Won't even fucking open my snaps. Won't even fucking reply to me. I'm literally dating a garbage bag.
I told you that a while. I told you that last
Like,
season.
the garbage bag was just stuffed animals and stuff. It's constantly say that back. He doesn't mind me food.
He was.
He doesn't mind me food anymore. So I don't think I like him anymore.
No, it's not that serious.
No, it's